working.
No.
We were on this problem. Has this been like haunting you for the last few days? What's going on? Yeah? Okay, so, and I remember very, very vividly that Janelle, right as the bell rang, was like, "Whoa," and she had like this realization that I don't know if everybody caught, and I don't know if you remember. I know, right? So I want to get you back to that point. So we were dealing with this question of Jason and Brent racing up a hill, and Dylan's been worried about them for, I don't know, a few days now. So Jason takes one path, Brent takes another path. The question that we started with was, how does the work compare for Jason versus Brent? And so then the question was, does the steepness matter, et cetera, et cetera. And so then we got into this little like tussle of a fight, and we weren't sure. So we did a little problem solving. Oh, there it is. That I need to find. So we did this example that I had told you we weren't going to do, and then I gave you the deal that we would. So then we were talking about somebody. Magda, was this you carrying a box up over it or something? I don't remember.
That was Tatum.
Oh yeah, it says, yeah. Anyway, so we've got somebody carrying something up a ramp. You remember this?
Yeah. Oh, they were the.
We're talking about work. Yeah, talking about work. So just a friendly reminder that work is the force times the distance, where the force and the distance are parallel. They have to be parallel. If they're not parallel, it's zero, right? Or we only take the part that is parallel. So we lifted this box up the ramp. We found this height using our trig, and we found the work done. And then I gave you a different ramp, a 9-meter ramp at 22.9 degrees. And right before the bell rang, we figured out what the work was required for that one. And what was it, Janelle? What did we find out?
It was 89.29 as well. Or no, the height was 3.5.
The height was still 3.5.
So that means it was the same.
And so you can find the work is the same. Yes. You guys with me there?
Oh, yeah.
Same height means same work. So stick that in your brain. Is that okay? So remember, moving forward, if we're carrying a pizza moving forward, there's no work done. Okay? If we're carrying a pizza up a ladder, yes, work is done, right? Because I'm pushing up. My displacement is the same direction as my force, and that's the thing that matters. So now, coming back to our friends that are running up the hill. Same height means same work. So what's the answer to part A? Same. Life is okay? Okay. Oh.
Okay. Sure.
So Jason goes up this super steep hill. Brent goes up this less steep hill. The horizontal distance that they travel doesn't matter. Only the vertical distance matters. Okay. So I've got a couple more, and then we are going to do a little lab today. So we'll make hopefully everybody happy. Do a little notes, a little lab. It'll be good. So I'm going to make this a little smaller, and I'm going to get rid of my space here. Boom. We'll make this big again. So part B says, is the power generated by Jason going up the hill greater than, less than, or the same as the power of Brent going up the hill? So take.
Going at the same time.
Well, let's take a look because I don't remember. It says, no, it says Jason takes 40 seconds. Brent takes 30 seconds. So is their work the same? Or excuse me, is their power the same?
No.
It is not. Do you remember what the equation was for power that we had?
Work divided by time.
Yay, work over time, right? So we'll write that down so we don't forget it. Power equals work over time. So who does more work? Or who generates more work? Or power, excuse me, power.
Wouldn't it be Brent?
Why Brent?
It's not.
He has the least amount of time, so if you divide it out, it should be.
Smaller time, more power?
Yeah.
Okay, sweet. All right, so I'm going to give you one more just real quick here. Just to make sure it's all, so we got Abby and Bonita. Very similar picture, did you notice? It's like they just changed the labels. Haha. These clever people. And I'm just going to put both of them up there for you in just a sec if I can get them. And then you can answer both questions. A few details have been changed, so take a careful look before you answer the questions. All right, do you guys want to talk for a second? Yeah? Or not yet? You're not ready to talk? Discuss. Go ahead and do it.
If it's the same height, it should be the same one. So
Yeah.
A is same.
I don't like the width of Abby.
But it wasn't that
Or
the
if
same
that
case
means
as the
that
last one.
Wait, no, that's exactly what they have the same weight.
We may just move there.
Okay, so Abby would have more than 1% of the shape takes more for Abby ground than me.
So then you can use the.
Already?
Oh, yeah. What do you mean already? I've been over it since.
It's only one.
It's 4 o'clock.
Yeah,
We're halfway through the day.
I suppose that's true. Depending on what time you wake up and what time you go to bed. This when you wake up and when you go to bed?
Pretty much.
I mean, I'm not judging.
So Bonita has.
How are you doing, team?
I think we're all right.
Are we ready for A?
Yeah.
Yeah, let's do it.
Abby.
Tell me about Abby. The work that Abby does going up the hill is greater than, less than, or the same as the work Bonita does. Greater than, I hear from at least one group. The same, I hear from one group. What am
Oh,
I?
I thought it was the same as well. But then, wouldn't the force of each of them be different
Why?
because of their weight?
Oh, yeah. Yeah, so when I said earlier, I was kind of misleading you, wasn't I? Wah, wah, on this one, same height, same work, same height for the same force equals the same work, right? Same height for the same force because it's the force times the distance. Does that make sense? And do Bonita and, is it Abby? Do they apply the same force to move themselves upwards? No, why not?
Because it says that one of them was running with something heavier, right?
Yeah, or it is just a bigger person, I think, really. Yeah, so Abby has a weight of 700 newtons. Bonita has a weight of 500 newtons. So which one has to apply a bigger force to get up the hill? Abby, because she's a bigger kid, right? That's fine. That means she does more work. That's all good. All right, so that means Abby does more work going up the hill than does Bonita. All right. Is that okay with everybody? Does that make sense? Or is there anybody that's unhappy about that? Because I could. Mark, you seem unhappy.
Wait, so if they were the
Wouldn't it
same
be
weight, they
Bonita
would be
that
the same.
uses more work?
Would it?
Because it's 500 times 100 compared to 700 times 60.
Where are we getting numbers from?
It's
So the
same
force
number.
times the distance.
It's
so-
30 meters high. So it's
Oh, okay, I'm using the different.
So we just want the height, right? Because the distance that they're applying a force in the same direction where that parallel thing is happening, the parallelness only happens over, what was it? The 30 meters high. Is that okay? The horizontal part, because you can think about it, one way to think about it is that there are an infinite number of ways for Abby to get to the top of the hill. The one she takes is this one right here. But she could go over this way and then climb straight up, right? She could go like this. She could go woo, like that. Are you with me there? Okay. But really all we care about is her distance, her displacement. And it's just in the same direction that the force is applied. Force is applied up, distance up, done. How we doing? Are we okay? Force times distance, work. So yeah, so Abby has to apply a bigger force because she's a bigger kid. So life is okay, I think. Are we good now? Yeah? And then part B, is the power generated by Abby going up the hill greater, less than, or the same as the power generated by Bonita? How do we do that? Do you have an answer for that one yet or no?
Just divide the work by the time.
Divide the work by the time?
Yes.
So tell me what I should write down, Dylan.
Well, to find the work, you have to, for Abby, it would be 700 times 30. And then find the work for Bonita, you have to do 500 times 30.
Then we have to divide, right? Oops, yeah.
Yeah, divide. Took Abby 40 seconds,
Mm-hmm,
and then it took Bonita 30.
mm-hmm. Do I actually have to do the math, or can you figure it out? Can you just look at that and figure it out? What's that? Yeah, why? Because my calculator says so? Yes, yeah. Because this is like a lot more, right? Whereas this is a little bit more, but it's not as much more. Yeah. We doing okay?
Where do you get the 30 from?
This 30?
Mhm.
That's the distance up that they went.
Oh, okay. I thought it was something else. Sorry.
Is that okay?
Mhm.
It's kind of annoying that they have a couple of 30s in there. So
Wait, it says. Oh, okay. Okay, never mind. Okay, you're right.
are you sure?
Yeah.
Okay, because I want to make sure that we're all on the same page. Okay. All right. It is time to do a little lab. And so I'm going to pause my video.